Hello everyone, this is Jude Leonard from Department of Physics, St. Joseph's College of Arts and Science, Kadalur. Now the discussion is all about types of diodes. Before to discuss about the types of diodes, we have to know what is a diode. It is a very fundamental nonlinear circuit, electrical circuit, and it allows the current to flow only in one direction, and this is the major usage of diode, and it is a fundamental part of any kind of semiconductor devices. Without diode we can't build a circuit, semiconductor circuit, and this device has two terminals, both anode and cathode, and in this anode is positive while cathode is negative. The important characteristic of this diode component is it has a nonlinear property. The current and voltage are of nonlinear property. Here is the set of diodes. What we are all about to discuss about this: Zener diode, the varactor diode, LED light emitting diode, photodiode, laser diode, Schottky diode, and pin diode. First of all, the first one is Zener diode. This Zener diode has a specific unique characteristic which allows the current in both the directions. It allows to conduct current in forward and in reverse direction, and it is a silicon semiconductor device. The diode is usually heavily doped p-n junction. The specification is to conduct the current in the reverse direction. When a certain specific voltage, a particular voltage is reached, it conducts the current in the reverse direction. As I mentioned earlier, it has very unique characteristics. It is a well-defined reverse breakdown voltage. It has a well-defined reverse breakdown voltage at which it starts conducting current. It continuously operates without any damage, continuously, even in the reverse mode. This is very unique about the Zener diode. Additionally, there is another quality. The voltage drop across the diode remains constant. It always remains constant, and this is a very important feature of Zener diode, which makes the Zener diode suitable for voltage regulation. It is highly used in voltage regulation circuits, and this feature is more suitable to conduct to fabricate a voltage regulation device. This is the image of Zener diode, where anode and cathode are the two terminals of this, and the symbol is represented as a mark over there, and this is a p-n junction doped. If it is heavily doped, it conducts in the reverse junction mode. So this is the image of a Zener diode. The next one is the varactor diode. The varactor diode is likely to be a capacitance diode. This diode has internal capacitance, and this varies in accordance with the variation of reverse voltage. So this type of diode are called as varactor diode. This is since it is a kind of capacitance, it is used to store charges. And this varactor diode, as a Zener diode, it also works in reverse bias condition. It is a semiconductor device which is highly dependent on a voltage. It is a specially designed semiconductor diode because when the capacitance across the capacitance of a semiconductor changes in accordance with the applied voltage across the terminals. This image represents the varactor diode, where there are two terminals, anode and a cathode, and there is a notation for parallel peak capacitor, since the varactor diode depends upon the capacitance. and this is the schematic symbol of that varactor diode. The next one is familiar diode for all of us, that is LED light emitting diode. It is a PN junction diode, a replacement of incandescent light. Usually we use incandescent light, so replacing that we use this kinds of LEDs light, which is highly power consumable device, and it is the principle of this is electroluminescence effect, where it converts the electric current to light. When electrons change states inside that LED semiconductors, there is a transmission of light. It is a combination of both N and P type semiconductor materials, which has sandwiched together to form a junction, and it comes as this junction is a transparent package, and this transparency allowing infrared and visible light to pass through the junction, and we get the emission of light. And there is an important thing to notice. LED works under a particular condition, that is the anode terminal should be in the higher potential when comparing to the cathode terminal. It means positive to negative. LEDs won't conduct if the respective terminals are connected in the reverse order. If it is connected in the reverse order, it won't work. This is the important condition to note it down, that LED should works. This is the representation of LED, both symbol and schematic representation. It has two leads, as you see in the image. The longer lead refers to the anode, and the flat surface refers to the cathode, and symbolic representation is represented over here in the image. The next one is the laser diode, and we all know that is a semiconductor device which produces high intense coherent light. The purpose of using a light laser diode is generation of light of high intensity, which makes the difference of all other laser, it means all other diodes. This is from the acronym of light amplification by stimulated emission of radiation, and we know that the stimulated emission is the basis working principle of this laser diode, and the purpose of using laser diode over the common LEDs is it has a high intense, and next one is due to the coherence of this laser diode we can replace LEDs. It means coherence means the light waves generated by this laser diode has having the same frequency and phase. So this is the advantage of using this laser diode. The next one is the photodiode. As the name suggests that photo means light. It is a PN junction diode that consumes light energy to generate the electric current. It may sometimes referred as photodetector or sensor or a light detector. It is highly designed to work in reverse bias condition. So reverse bias means the P side of the photodiode is connected to the negative terminal, and N side obviously connected to the positive terminal of the battery. And this shows the schematic representation of a photodiode, where light source incident on the p-type material, and there is a silicon dioxide mask is coated over the p-type material, and there is a surface of cathode and anode, and there is a n-type of bulk silicon layer represented, and depletion layer is formed over the PN junction, and which makes the light rays to convert as into a electric current. The next one is a Schottky diode. And you see here the semiconductor and a metal junction are formed between the layers, and thus creating a Schottky barrier. The N-type semiconductor acts as a cathode, and the metal side, usually P-type, is replaced by a metal side diode, that is junction, and it acts as an anode. This particular barrier results in both low forward voltage drop across the terminals will result in barrier, and this is very fast in terms of switching. It is very fast. It is also called as hot carrier diode, and the semiconductor diode, which has a low forward voltage drop and very fast switching action. So this diode, the purpose of using this particular diode is for switching action. And there is also a small voltage drop across these diode terminals when current flows through the diode. As we discussed about the Schottky diode, this representation, pictorial representation of a Schottky diode is over here, where N-type silicon material is acting as a cathode, and usually P-type is replaced by a metal type of material, and it is termed as anode. This is the representation of Schottky diode. And the last one is the pin diode, and the pin diode is formed by sandwiching the intrinsic layer, usually which has high resistivity. The layer between P and N-type semiconductor creates an electric field in the layer. In the junction, due to the sandwiching of intrinsic materials, they produce electric field. Due to this large magnitude of electric field created over there in the junction, creates an electron hole pair, and to a large extent, and in turn it can processes even a weak input signal. This is the main usage of this electron hole pair, which produce, and even in the weak input signal it can use to a very large extent. And this is the usage of this pin diode is a high voltage rectifier in the rectification process. The large width of intrinsic layer junction in between P and N imparts the ability of the diode to tolerate high reverse voltage without leading to the breakdown of the diode. So due to the larger width of that junction, it tolerates even in the high reverse voltage. It doesn't leads to the breakdown of the diode. And the usage of this pin diode is mainly in the radio frequencies and microwave switching, where this diode needs to be operated even in the reverse bias condition. This is the pictorial representation of pin diode, where photons is impinged on the N substrate. So there is a depletion layer in between N and P substrate, and both cathode and anode are the two terminals of this diode, pin diode. Thank you for your listening.